You're not going to want to miss this episode of the AI Show where we talk to Paul and Alvin about NVIDIA DeepStream development with Microsoft Azure. Make sure you tune in. Hello and welcome to this episode of the AI Show. We're talking all about NVIDIA DeepStream development with Microsoft Azure. We've got Paul and Alvin with us. Why don't you introduce yourself? We'll start with you, Alvin.
Yeah, hi everybody. My name's Alvin. I do product marketing for the NVIDIA AI SDKs. So really, my job is to help users embrace the power of AI with software tools, making it easy for everybody to do
You're already making me happy, Alvin. Let's go to
it.
you, Paul.
So my name is Paul DiCarlo, and I'm a lead within the data and AI team over here in developer relations at Microsoft. And a lot of my day-to-day work slash interest often involves how can I make some hardware thing from NVIDIA work with some cool cloud thing from Microsoft. And it's a never-ending joy because there's always something new and exciting from both sides, and it's very fun to find out ways to use them together.
Well, I'm a fan for sure of Paul and the work that you do, Alvin. So let's start with NVIDIA DeepStream. Alvin, can you tell us a little bit about that?
Yeah, absolutely. If you, Paul, if you want to bring up that slide.
Yeah, let me get that right now. Here you go.
Yeah, great. So, yeah, anybody that's ever dealt with video or image processing knows that there's just a lot of rabbit holes. You can get into the mathematics of scaling, of changing color space conversion. You can get into how do I, share frame buffers, pointers, because you got video coming in at a steady cadence, 30 frames per second, 60 frames per second. And of course, once you have your AI inference model, you of course want to run that as efficient as possible. So DeepStream is all about end-to-end optimization and acceleration. We're built on top of GStreamer. That's a open source community that said, hey, building this video pipelines, we need an easier way to do that, to do so. And so we kind of built on top of that and say, hey, how can we make the input, the capture, the decoding, the pre-processing, the backend, the tracking, all work as efficiently and optimized as possible, whether you're running on a Jetson device, whether you're running on one of our discrete GPUs, or whether you're throwing your application up on the cloud.
Interesting. So let me see if I understand this right, because I'm a computer vision guy, not like a TED Talk guy, but like the actual pictures and stuff. So you're telling me that what DeepStream does is it takes like video streams and does a bunch of conversions on it to prepare it for machine learning or for any other application. Am I getting that right?
Yeah, absolutely. Yeah.
So
So we take things. Let's say you're running on a Jetson device and you got a RTSP stream coming in. So we're ensuring that decode is happening with our NVDEC. So you're using that hardware accelerator when you're putting in that pipeline. Let's say you got to do scaling or you got to do color space conversion. So you want to make sure you're doing that on the GPU. You want to use our GPU CUDA cores or et cetera, so that it's all about computer science. It's all about Amdahl's law, right? When we kind of talk about the efficiency is only as good as your kind of how good you're running that slowest part. So for example, you got 30 frames per second coming in, 33 milliseconds. You built this awesome AI model. It runs at 2 milliseconds, but when you actually go to put in your input stream, you find out that your decode is taking up 40 milliseconds. You're scaling certain 45 milliseconds, and all of a sudden you're scratching your head going like, hey, why am I only getting 10 frames per second? So what DeepStream does is ensuring that you're not starving that AI inference model. You're giving everything as efficiently as possible. And the same thing that the back end, whether you're doing tracking, video analytics, throwing stuff up to the Azure cloud, that's running as efficiently as possible so it's not throttling the upstream video pipeline.
that makes a ton of sense. So whenever I'm seeing like those images of like cars and boxes around it, all of that video needs to get processed. And what you're saying is that we want to process that on the GPU so that those boxes can be drawn clearly once the inference time is happening. Is
Yeah,
that about right?
absolutely. Yeah, and even the output video rendering, right? Like drawing the bounding boxes. That you want to do that on the GPU, and you want to render that using the GPUs, because imagine everything's running on let's say you got the inference, so that video frame is down in the GPU memory. If you want to say, okay, I'm going to go draw the bounding boxes with my CPU, then that memory is going to come back up to the system memory. You're going from kernel to user space, then you're drawing it, then you got to send it back down, and then all those copies just take up a lot of time, and so your end-to-end latency really hurts. If you're able to take advantage of what GStreamer and DeepStream do, is you're keeping those frame buffers down in that accelerator memory, and you're getting that accelerator to not only do inference, but also potentially do the video rendering, the bounding, box drawing, and so it kind of helps accelerate everything end to end.
And that makes a ton of sense. And when you said like a Jetson Nano, I want people to know a Jetson Nano is like a tiny computer thing, right? It's like the size of a credit. Oh, look at it.
Yeah, there you go. Paul's showing it.
Paul's showing here. Let me make us bigger. Show it that thing. So you're talking about doing all of this on that thing, right?
Yeah, absolutely. Yeah. No,
So
what's really nice about DeepStream, and it expands to that, is that you put together your pipeline, and assuming all the resources are there, you run it on the Jetson. That same application can run on a discrete GPU. You can send that same application to the cloud. You don't have to kind of recode it. Let's say you support one camera stream on a Jetson Nano. You go to a discrete GPU. You can execute that same pipeline multiple times, and now you're supporting 50 streams, 100 streams, 150 streams on a discrete GPU. So it sort of scales and has the agility there. That's when you're putting together these applications.
So let me ask the hard question here, Alvin, because when I look at this stuff, I'm like, those are some cool boxes, but now I'm going to have to write some C++ or something. Is this what I have to do? So help me out. How do I actually use the SDK? Am I going to have to?
Yeah. So if we can go to the next slide. So it all starts with those hardware accelerated DeepStream plugins that I talked about, right? Those are those blocks that make up the video pipeline for like the decode, the scaling, the tracking, and those are all optimized. Now you can work with those both in Python and C++ from a coding standpoint. But then you're starting to have to know a little bit about how GStreamer works, the configuration, syncs and pads and all of that, especially if you're going to do a little bit of customization stuff. And so for this last version of DeepStream 6.0 that came out in November, we wanted to take the ability of DeepStream and being able to do it visually with visual programming. And that's where Graph Composer comes in. And that's the newest way of being able to develop with DeepStream. So we're already visualizing this video pipelines in our heads as, hey, I got my input stream, I'm going to do my decode, then I'm going to send it to the inference. I might want to tap here and then look at how much FPS I'm getting, and then I'm going to do my on-screen display and my video rendering. And we said, well, why not just create a visual programming method so that you're actually programming DeepStream in that way? The way you're visualizing it, let's do it with Graph Composer. And any of those things, you can then, as you can see, you can take Container Builder, which generates little Docker images, and you can send them anywhere from Jetson to the cloud. So early on, we, of course, reached out to Paul and said, hey, Paul, we got this kind of cool new low-code, no-code way of creating these DeepStream processing pipelines. Do you want to take a look? Do you want to see what it is and give us some of your feedback?
Well, this sounds awesome because I have used GStream because I wrote, people don't know this, but I wrote a little bit of Learn TV, like the back end, production. If you're watching on Learn TV, I wrote the back end, and that stuff is hard. And so if you're telling me that I can totally just embed like machine learning and post things and pre things into the video pipeline with just drawing, I'm not going to believe it until Paul shows me. So Paul, what do you got for us?
Well, I'm happy to share that it's real and it's here. This is it, the NVIDIA DeepStream Graph Composer. And what you're looking at here is a very simple representation of a DeepStream graph, which you can think of as a representation of an intelligent video application that's powered with the optimizations and SDK components that are part of the NVIDIA DeepStream SDK. Now, what you'll notice over here on the right is that the IDE sort of comes with a collection of extensions which inside of contain components. And these can be dragged and dropped onto the canvas area. And depending on the properties of that component, you can then connect compatible outputs into compatible inputs depending on the features that you're intending to use. Now, in our case, we're going to start over here on the left with our NVIDIA DeepStream single source input component. And what this is going to allow us to do is bring in an input in the form of either a video file or even an RTSP stream. And we can then connect that into something we call the NVIDIA Stream Muxer. Now you might be wondering why we're using a muxer here. Well, you're not just limited to using a single video source input. You could actually create multiples of these. In fact, I found that on the NVIDIA Jetson embedded line that the smaller Jetson Nano device can handle up to 8 of these inputs simultaneously. And similarly, if you go higher onto something like the Jetson Xavier, that could handle up to 32 simultaneous video inputs into a muxer, which can then be output into your inference step. And this is where we actually choose the object detection algorithm that we're going to apply to that video input. So in this case, we're using a ResNet 10 4-class object detector. And you'll notice that the output of this step then splits off into an NVDS per class object counter, which allows us to accumulate a running total of each object that is seen during those inference steps during the processing, and something called the NVDS OSD, or on-screen display. And this is going to allow us to draw bounding boxes over those detected objects within the output that is coming from the inference step. And finally, it's going to allow us to render those results or draw them back in a visual representation using the NVDS video renderer. Now, one of the things that I absolutely love about the Graph Composer is because it is an IDE-like environment, it allows for a very, very tight loop for you to be able to build your application, and not only that, be able to see it executing so that you can very quickly make iterations to that as you're developing your pipeline. So I'm going to go ahead and select the Run Graph icon over on the left, choose my available options, and then select Run. And this is then going to give us the visual representation using all of those selected components that make up our graph. And as you can see here, it's drawing those bounding boxes using that ResNet 4-class object detector. And it's also giving us an accumulated total of the objects that it's seeing in the upper left hand here. So this is really awesome. And again, not only can you really quickly make those updates, changes, and see them, but if you think about it, if you ever think about modifying that pipeline or adding additional features, it makes it very, very easy to come in here, select a new component, and then see that working in action. So for example, say we wanted to push our data into the Microsoft Azure cloud. Well, the good news is there is something called the NVDS MSG Conv Broker, and this can allow you to connect to an MQTT input or output or channel, and also allow you to use shared kernel objects that can give you native compatibility with things like Azure IoT Edge, allowing you to push object detection results from your inference step directly into, say, an Azure IoT Hub, where it could then be processed by a myriad of services that are available within Microsoft Azure. But it doesn't just stop there. Once you've actually built up your solution and you're ready to go to production, it has a built-in feature known as the container builder that you can invoke by selecting this cloud icon over here and choosing build container. And from here, you can give it a configuration file that will allow it to point to the specific representation of this graph, and a platform configuration file, which means that you can choose to target building a container that can run either on an x86 discrete GPU desktop machine, maybe run in an Azure virtual machine with compatible NVIDIA hardware, or even deploy down to ARM64 devices that may be part of the NVIDIA Jetson line so that you can build something that runs on the edge. So once you've got those configurations and platform configs set, simply select build, and this will invoke Docker in the background to start building up that container for distribution. Now, in the short time that we've had in this demo, we've talked about a lot of the really cool features that are possible, but what I'm really excited to share is that we've actually got an interactive learning path on Microsoft Learn that walks through the steps to not only install the Graph Composer, get started with it, give you a little bit of background on DeepStream as well, but then shows you how to build these containers and deploy them out to an Azure IoT Edge device. And so here you can see that, And it's a really awesome thing that you can go ahead and test drive today.
No, that totally makes sense. It's basically because before I would have to write some code, I would do stuff on the GPU, and then I'd have to bus it on over, to the CPU, and then do stuff. And then you're saying all of this is happening in that single pipeline of stuff.
Yep, exactly.
Correct.
And that's
Yeah, and
the thing
within
I like
that
the most.
environment, yeah, and it's so easy to iterate, right? You can just start with a blog, start with a video renderer, just verify that you can
Someone's at the front door.
verify that your video is playing, and then you can just start adding block and test, and it's very easy to you can do very easily do probes. One of the other cool things that Paul didn't touch on is that, let's say you're already using you have a custom GStreamer plugin, or let's say you have a particular camera and that camera vendor has or provides a GStreamer plugin in order to interface with that camera. Graph Composer allows you to automatically create extensions out of existing GStreamer. So all you have to do is, as long as GStreamer can find it, it's installed, GST inspect, then you just bring up that menu, say, hey, this is the plugin I want to wrap through an extension. It'll generate it, it'll be there. So it's very easy to incorporate your own custom GStreamer or DeepStream extensions, as well as third-party plugins as extensions in Graph Composer.
I mean, it's really cool. Like, and the fact that, and I don't know if people recognize, but just that entire pipeline, you having to write that yourself, weeks, if not months of figuring it out. And you're saying now I'm going to have to download it post haste, because it's something I've been wanting to do for a long time. So let me ask you just a couple of final questions here. Where can people go to find out more about this?
So developer.nvidia.com and the product page for DeepStream SDK. There's going to be a getting started link, has everything great. But really the learning path that Paul has put together is really, really great in terms of an introduction to Graph Composer. So I have been, even though it's from Microsoft, we work jointly with it. And it's kind of my go-to when someone tells me, hey, how do I learn Graph Composer? And I'm like, go talk to my buddy Paul. He's put this thing together. It's free. It's available. It's great. And yeah, so I can't rave enough about it.
Awesome. So Paul, can you give us maybe a 15 to 30 second elevator pitch on what the Learning Path will do for folks if they go to it?
Sure, absolutely. So it's actually comprised of 3 modules that take you all the way from the steps involved in setting up and configuring the DeepStream development environment. So this is going to be how you actually install any of the dependencies, what those hardware requirements are, for example, what sort of graphics cards you might need, gets you up and running with your sample applications. And from there, you're already going to start doing damage in an optimized fashion with some sample DeepStream applications. But then we go further. After we sort of give you that taste of what is DeepStream, we then show you how you can use Composer. And again, I think it's very important that you learn them in that order, because if you just dive into Composer without knowing DeepStream, you're not going to really know, I guess, the damage that you could do with the tools that are included there. And from there, that's going to allow you to basically understand how you can build applications. But not only that, it's going to give you a deeper understanding of those containerization options that we sort of showed there earlier, or sort of glossed over, and show you how you can even publish those into an Azure Container Registry. And then the final piece that I think is absolutely the most important is deploying those containerized DeepStream workloads to an embedded device utilizing Azure. And we actually go through and do this using the Azure IoT Hub and something called Azure IoT Edge.
Oh,
so this allows you to orchestrate and deploy this sort of at scale. And if you had a fleet of devices, shows you how to do that and get those up and running, and really teaches you how you can go not just from creating that pipeline, but go to production with a true edge to cloud AI inferencing solution powered by NVIDIA and Microsoft.
Yeah, what's really great about Graph Composer is, even though it's visual programming, it might look like, hey, this is great for hobbyists or whatever it is, but you can really build market-ready products with it. There is no performance degradation. All the extensions all the way underneath there, it's still our optimized engines and software blocks and stack. And so it's really, you're getting all the power of DeepStream, all the power of your NVIDIA platform in a really easy to use, intuitive UI in order to build these vision applications.
Well, I'm going to go and download that right now. Again, if you want to learn more about the DeepStream SDK, just go to developer.nvidia.com/DeepStream SDK, and then the Learn modules that you saw Paul so wonderfully created for all of us at KA.MS Learn DeepStream. Thank you so much for being with us, my friends.
Yeah, absolutely. Anytime.
Awesome.
It's a pleasure.
You've been learning all about NVIDIA DeepStream development with Microsoft Azure on the AI Show. Thanks so much for being with us, and hopefully we'll see you next time. Take care.